All right, check, mic check. Good evening, everybody. Welcome into another live stream. Today is October 16, 2025. Juan, welcome in. You're the first one in. Anyone that is new here, welcome in. We are just getting started for today. It is 6:22 p.m. PST, 9:22 p.m. EST. Guys, anyone that is new here, my name is Dr. Andrew Sanchez, PhD in Chemical Engineering, and in today's live stream, we are going to go over all your topics and STEM questions you might have regarding organic chemistry, general chemistry, mathematics, or physics. Let's get up the poll. We're only going to do 40 minutes on the clock today. What topic should we cover today? Should we start off with general chemistry, organic chemistry, physics, or calculus? And give you a second to think about that as I pull up the poll. Peach, welcome in. How's everyone doing today? Do you guys have midterms, finals, exams coming up? Are you guys feeling good or cooked? What's poppin'? Just getting started? All right, so what topic should we cover today? All right, 40 minutes on the clock today. I'm only going to be on for about 90 minutes today, which is still pretty good, but not as long as usual because I do have quite a lot of meetings today. All right, so Juan was the first one. Juan says physics right away. Cool. Got one for organic chemistry. B, make sure you vote in the poll. So, as usual, I think what I'm going to do is let me pull up the schedule, and let's work on the schedule today because today is going to be a little bit different. So today is going to be Thursday. I'm going to work on the schedule real quick. We're going to be quick today because I don't have too much time, unfortunately. So it's going to be, right now, it is about 6 o'clock. Okay. So we're going to do basically AP Chem and General Chem. And then whatever is going to be the next topic, we'll do that at 7 o'clock or 10 o'clock EST. Cool. And then if I missed you, then you can join up on the Discord and drop in your questions up on the Discord. Nathaniel says, can you go over p orbital mixing in aromatic anti-systems? Aromatics, okay. So guys, make sure you vote for the poll here. What topic should we focus on today? Martin says, I got a Calc 1 midterm. Martin, good to see you. How are you doing? Eric, how are you doing, buddy? Can you go over dynamics for AP Physics 1? Is tutoring a lucrative career? Guys, not gonna lie, so far it's kind of a mid-career. But I have confidence that I will make it lucrative. Let's pull up that poll one more time, and I think we are gonna get started today with general chemistry. So whatever you want to vote, make sure you vote up on the top left in the top left-hand side corner for that poll here. Let's see which one's winning so far. We got one for Gen Chem, one for Physics, one for Calculus, none for Organic Chem. So guys, welcome into the chat. Anyone that is new here, my name is Dr. Andrew Sanchez. We are just getting started here for today. If you're new here, comment the word new so we can welcome you in. If you're new here, comment the word new. You gotta comment the lock emoji because you know we're about to lock in. Emmy, welcome in. Emmy's new. Eric is new. Guys, if you are in general chemistry, we're going to get started right away. But before we do, I just want to let you know about myself and what it is that I do here. All right, my name is Dr. Andrew Sanchez. Welcome to Engineering Minds. I do have a PhD in chemical engineering, and I go live every single week, Monday through Thursday, right around this time, 6 o'clock PST, 9 o'clock EST, to answer your questions for STEM. If you need any help regarding chemistry, mathematics, physics, or engineering, I got you covered. You can sign up for a free tutoring session at the link in my bio. Just go to engineeringminds.co. You can also join the Discord, which is totally free, as well as explore resources here on the brand new website. That's engineeringminds.co. And once again, I offer tutoring for various STEM subjects, including physics, whether you're in AP Physics or college physics, chemistry, whether you're in AP Chem, college Chem, or organic chemistry, mathematics, including trig, pre-calculus, calc 1, 2, and 3, and engineering. All right, guys, that's enough about me. Now tell me about yourself. What classes are you guys taking? Are you feeling good or feeling cooked? Are you feeling ready for your exams or feeling absolutely fried? First thing on the clock, we're going to start with the Gen Chem review. So if you want to do Gen Chem, feel free to stick around, get your notes, and let us know what topic for Gen Chem we should focus on today. If you're feeling cooked for a particular class, don't even worry. We're going to go over as many questions as we can today, but make sure you vote up on the top left-hand side of the poll. Emmy says organic, Eric says cooked, Zach says calc, and trig. Guys, let me know if we're going to do Gen Chem. I like to start off with Gen Chem for the first 30 minutes, and then we're going to do our Q&A section. At the moment, we have a poll, so make sure you vote up on the top left-hand side of the screen, guys. Make sure you vote on the top left-hand side. Let's bring that up one more time. And we're going to get started on our Gen Chem session for the next 30 minutes. Guys, anyone that is in Gen Chem, say here. Anyone that is in General Chemistry or AP Chem, say here, because we are going to do Gen Chem first. And then in 30 minutes, we're going to do whichever one is the winner. So if you're in Gen Chem, please say here and let me know what we should focus on today here. All right. Cooked in P-Chem. Guys, I see like not that many people in Gen Chem today. So random question. What is your favorite math concept? Okay, so I do see Aline is in Chem. Perfect. So we're going to do Gen Chem first, guys. My favorite math concept is... would it be cheap if I said vectors? I'm going to just go with vectors. I'm going to go with just vectors because they're used in physics, they're used in engineering, they're used in linear algebra, they're used in computer science. All right. Good evening, Jared. You're in for a treat because we're starting with Chem today. All right, guys. So now if we're starting with Chem, what should we focus on today? Should we do a review of stoichiometry or jump right into it with our limiting reagents and whatnot here? So I'm going to start by doing a quick review and then waiting for people to drop their Chem questions because I know a lot of Chem people chime in here. So let's start off with a Chem review. For example, if I have NaCl, guys, go ahead and comment down below what kind of compound are these here. Let's say NaCl. Is that ionic or covalent? I'm going to do a quick review and then we're going to jump right into it with our stoichiometry. Okay, ionic or covalent. Juan says limiting reagents. Marlon says stoichiometry. Chem 2. Jaha says icebox. Okay. So Chem 1 or Chem 2, chat? Chem 1 or Chem 2? Guys, let me know if you guys understand these here. Ionic or covalent? And then also, how do we break apart these compounds here? For instance, Na here is going to be Na plus here, right? It's going to be Na plus and Cl minus. Okay, Daniel says Chem 1. Kiki says Chem 1. Both ionic. Okay, very good. Both ionic. So I'm going to say Mg2 plus here as well. Oops. Mg2 plus. Okay. And Cl2 Cl minus. Very good. Okay, guys. So I think what we're going to do is our first topic. That was a quick little warm up. I think our first topic is going to be stoichiometry and limiting reagents. And if we have time, we're going to do the Rice table as well. Okay. So I'm going to go ahead and do the stoichiometry section here. Stoichiometry review. Grams to moles, moles to atoms, limiting reagents, things like that. If stoichiometry is a good topic, go ahead and do me a big favor, chat, and put a thumbs up down below. If stoichiometry is a good topic for us to focus on today, go ahead and drop a thumbs up to low to let me know that this is a good topic. Okay. All right, Gio says thumbs up, so I think we're about to lock in for some stoichiometry. Sarah, welcome in, Gio. Jared says, heck yeah. Marlon, all right. Marissa, all right, awesome chat. Once again, guys, welcome into the chat. My name is Dr. Andrew Sanchez. We are just getting started for today. If you're new here, comment the word new so I know you're new. If you've been here before, comment the lock-in emoji because you know we're about to lock in. Our first topic today is going to be Gen Chem, stoichiometry. So if you're taking AP Chem right now, if you're taking College Chem, go ahead and get out your notes. I highly, highly recommend you actually get out your notes and follow along as if this was a real class. Lisa, new, welcome Nisa, welcome Isa, welcome Nadia, welcome Sarah, welcome Daniel. Again, I highly, highly recommend you get out your notes. Guys, you can join the Discord for totally free. We're going to drop all the notes after this. And I am recording this live so you can rewatch this entire thing after this is over. Hello, Muzzy. No, you, the goat. No, you. We can definitely do calorimetry, but I'm seeing a lot of thumbs up for stoichiometry. Guys, for stoichiometry, I need a recipe here. So what's another recipe that we can go over? Last time we were using plátanos, and what did we do last time? Last time we said plátanos plus chicharrones equals mofongo. So we need another recipe. So someone give us another recipe, okay? So that we can discuss stoichiometry as a quick warm up, okay? So what's a good recipe? What's gonna be something, an ingredient that we can have here, and a product on the right hand side here? Ooh, I can definitely calculate that, Jared. Can you remind me later how many picometers is it to Jupiter? We can calculate that. Me plus you equals friends. Okay, that's not bad, but I need some kind of quantity here, guys. I need some ingredients. So chat, go ahead and start listing some ingredients here. Ingredients. Okay, and then I need a product. Okay, it can be sandwiches, it can be car parts, it can be a bicycle, it can be any type of ingredient. What is it going to be today? Is it going to be Krabby Patties? Is it going to be, I don't know, sandwiches? Okay. All right, 6 eggs plus 7 cups of milk. All right, 6 eggs plus 7 cups of milk. What is that going to make? What is that going to make? I really like that. JJ says 6 eggs plus 7 cups of milk. What is that going to make? What are we going to make today, guys? 6 eggs, 6 eggs plus 7 cups of milk plus 7 cups of milk. What is that going to make? Okay, what is that going to make, guys? Guys and gals here. So what is our product here? A mess. Jared says it's going to be a mess here. But what is the product here? What is the product? Is it going to be cookies? Is it going to be cake? Pancakes. Pancakes. All right, today we're making pancakes. Yummy, yummy. So we got 6 eggs plus 7 cups of milk equals 6 to 7 pancakes. Let's go ahead and make 7 pancakes here. Okay, 7 pancakes. So someone says we need flour, but let's just kind of simplify it, guys. Let's just kind of keep it simple. We have 6 eggs plus 7 cups of milk is 7 pancakes. Guys, this is how we do stoichiometry. This is general chemistry. This is how to make Gen Chem super fun and easy. All right, now we're going to go to the store, and let's say how much did we buy at the store? So we have, how much did we buy at the store? How much did we buy? We bought at least 6 eggs and 7 cups of milk. So someone give me 2 random numbers between 1 and 100. The first 2 random numbers are going to be the winner. Okay, yes, this is really Gen Chem. This is actually general chemistry. We're just doing a warm-up here so you can understand stoichiometry and limiting reagents. All right, so JJ said 67. He's really a fan of 67. So JJ said 67 eggs, and then, okay, I'm going to use another one because Gio said, Gogo said 56. So we went to the store, we bought 56 eggs. Okay, we bought 56 eggs, and then we also bought, Marissa says 45. So we bought 56 eggs and 45 cups of milk here. 45 cups of milk. All right, our goal is to calculate what? How many pancakes can we make? How many pancakes can we make here, guys? That's going to be our calculation here, and this is exactly what chemistry is like. Don't believe me? Stick around and find out. This is how we're going to figure out our calculation. All right, anyone that's been here before, what's going to be step 1? Anyone that's been here yesterday or this week, what is step 1 always going to be that I want everyone to understand? Step 1 is always going to be what, guys? Always going to be what? Okay, how do we make chemistry easy? Step 1 is always start with what? Jared says cry. So now people can't move sticks. Not perfect. Guys, don't be fighting. Don't be fighting. All love. Ask ChatGPT. Yeah, guys, don't be pressed here. Okay, guys, so if anyone's been here, if anyone's not been here before, the way we're gonna do this is we're gonna step 1 is gonna start with what we know. Okay, step 1 is start with what you know. Okay, step 1 is start with what you have. Let's say start with what you have. So what do we have? Okay, we went to the store and we have 56 eggs and 45 cups of milk. So that's where I'm gonna start. That's where I'm gonna start. Okay. You got the handwriting with doctor. I know, I'm sorry, guys. I'm trying to work my handwriting, but it's so hard. Okay? Because I'm using my iPad here. Start with what you have. Let me try to be a little bit better. So start with what you have. So what do I have? Okay, I have 56 eggs. So I'm going to write 56 eggs over here. I'm going to write 56 eggs right over here, right? Okay, so I have 56 eggs, and then I'm going to end with what I want. Okay, I'm going to end with what I want. So what do I want here? What do I want? So, do I want milk or pancakes? I'm going to want pancakes, right? Hello, Jess. Good to see you. We are just getting started today. Hello, buddy. Guys, do I need to mute some folk? What's going on here? Okay, 56 eggs 6 months ago, you'd be richer than Bill Gates. Okay, so I'm gonna end with pancakes. I'm gonna end with pancakes. So I'm gonna end here on the right hand side. Okay, so what are we gonna put on top? What are we gonna put on top? Very good. Okay, so we're gonna put on the bottom here. What are we gonna put on the bottom here, guys? I'm gonna put 56 eggs here on the bottom. No, we're gonna say 6 eggs here on the bottom. Okay, so I'm gonna say 6 eggs here on the bottom, and then 7 pancakes up on top, right? If that makes sense? So if this makes sense why I put eggs on the bottom and pancakes on top, put a thumbs up. If this made sense why I put eggs on the bottom and pancakes on top, go ahead and drop a thumbs up down below. So the reason I did 6 eggs here was because we go to the recipe here, it says calls for 6 eggs. So the recipe calls for 6 eggs. Let me try to be a little bit neater today, guys. So the recipe calls for 6 eggs here. And then I'm going to put that 6 eggs on the bottom. Why? Because I want to cancel that out. So I'm going to cancel out my 6 eggs with my 56 eggs here. And then I'm going to put my pancakes up on top here. So now my pancakes is going to be up on top here. Okay, so who can calculate? So someone please calculate 56 times 7 divided by 6. 56 times 7 divided by 6. Let's see what that's going to be. Okay, so 56 times 7 divided by 6. Let's go ahead and calculate that out. Okay, so I'm gonna do 56 times 7 divided by 6. Loud out calculator. 65.333. Oh my gosh, that's a lot of pancakes. We got so many pancakes here. 65.333. That's a lot of pancakes here. Wow, we're gonna be feeding. We are cooking today, chat. We are cooking today. We're gonna make 65 pancakes. We're gonna be cooking up some pancakes today. All right. Cool. Yeah, enough pancakes to run an IHOP. I don't know about that, but it is quite a lot. We are cooking up. It is enough for everyone in the chat and more. It is enough for everyone in the chat and more. All right, now what's the next step? All right, now what's the next step, chat? So now I have 65.33 pancakes here. Okay, what about sig figs? We're going to do sig figs at the very end. Okay, we don't want to do sig figs in the beginning because we don't want to round our errors here. So we're going to do sig figs at the very end. So what's the next step, chat? Does anyone remember the next step? So the next step is I'm going to start with what I have. I have 7 cups of milk. So I'm going to start with my 7 cups of milk. So now what does the recipe call for milk? So how much am I going to produce with my 7 cups of milk? How much am I going to produce with my 7 cups of milk? Okay, so I don't get pancakes. It's the same ratio, 1 to 1. Okay, good. It's the same ratio. So now I'm going to use 7 cups of milk. I'm going to put this one in green. And then I'm going to say, oh, look, I have 7 cups of milk. So I'm going to put, oh, wait, I'm sorry, chat. I meant to put 45 cups of milk. My bad, chat. I meant to put 45 cups of milk because this is what I have. So I have 45 cups of milk. And then I'm going to divide by my 7 cups of milk here. Okay, so now I'm going to divide by my 7 cups of milk because that's a part of the recipe. All right, very good. So now I'm going to make another 7 pancakes. It's a 1 to 1 ratio. So that's going to essentially cancel out. What's my final answer, chat? What's going to be my ratio here for my final answer? This essentially goes away. So my ratio here, 7 divided by 7 goes to 1. I got 45 cups of milk. Now, which one is limiting? Which one is limiting? Is it going to be the eggs or the pancakes? Which one is limiting? If you think that eggs are limiting, comment the word eggs. If you think that cups of milk is limiting, go ahead and comment milk or use an emoji. Okay. Weir says milk. Miles says the cow. Jess says milk. Good job. Jared says sore hands. Jose milk. Juan milk. Good job. Okay, Jess says milk. I see milk. Good job. Everyone's saying milk. So why did you say milk? Milk is the limiting reagent. Okay, milk is limiting. So let's label that. So if milk is limiting, why did you say limiting for milk? If this one's limiting, then this one's going to be in excess. So at the end, we're going to have only 0 cups of milk remaining. Why is that? Okay, because it produces 45 pancakes. Exactly, right? Because we got limited. Very good. So we got 0 cups remaining, but we produced, how many pancakes did we make, right? We did our calculation here. Is going to be 45 pancakes. So I have 45 pancakes. Now the very last step is now we have to back calculate how much excess we have remaining. So how much excess do we have remaining, Chad? We started with 56 eggs and 45 cups of milk, and then we produce 45 pancakes. How do I calculate how much excess is remaining? Can we say it's 45 with the period after? I think that like that number of sig figs. Guys, I feel like I'm gonna do sig figs at the end. So for sig figs here, I'm gonna do, okay, sure. So this is at the end, so I'm gonna do 0, and then I guess I should do 0.0, shouldn't I here, guys? Technically, I should do 0.0 for 2 sig figs. All right, we're gonna subtract, but not yet. We're gonna subtract, but we have to like carefully think about when are we gonna subtract. First, we gotta multiply, okay? How did you get 45 pancakes? Weren't you supposed to multiply or divide by 7? The reason I got 45 pancakes here was because I divided by the 7 cups of milk here in green, okay? And then I multiplied by my 7 pancakes here. So I consumed 7 cups of milk on the bottom, and then I produced here 7 pancakes up on top. Does that make sense? So that's how I got my 45 pancakes. All right, so someone said 67, so let's see how you guys got the 67. So I'm gonna start with my 45 pancakes, and then I gotta see, now I gotta go backwards. I gotta use my pancake conversion factor to back calculate the amount of eggs that were consumed. Are sig figs still as annoying when you're in your career? Definitely not. No one cares about sig figs in real life, guys. Definitely no one cares about sig figs. It's just like in 3rd grade when your teacher said, oh, everyone needs to learn cursive because you're going to learn cursive in real life. Nope, not true. Same thing for sig figs, guys. You're not going to need sig figs in real life. You are going to need it for science a little bit to round your results at the end, but you're not going to really need it. Okay, so I do a little bit of sig figs for my publications, but not really. Okay, so I put 7 pancakes on the bottom and 6 eggs up on top. So guys, does everyone understand why I put 7 pancakes down here and 6 eggs up on top? If you understand why I put 7 pancakes down on the bottom here and 6 eggs up on top, go ahead and do me a favor and drop another thumbs up down in the chat. So drop a thumbs up if you understand this conversion factor. 7 pancakes on the bottom so I can cancel out my pancakes, and eggs up on top so I can get my eggs consumed. Okay? My teacher did this same exact example when I learned Chem junior year. Glad to see it. Awesome, Gio. So guys, do we understand why I did the 45 pancakes is 6 eggs to 7 pancakes? Okay, Jess is a little bit confused. No worries, Jess. So let's discuss my 45 pancakes here. So I have 45 pancakes were consumed, now were produced. Now I'm trying to calculate how much eggs I have remaining, right? So first I went from eggs to pancakes, and then I went from cups of milk to pancakes. Now I'm trying to go backwards, Jess. Now I'm trying to go backwards from pancakes back to eggs. So if I'm trying to go backwards from pancakes, I'm going to start with pancakes here up on top. And then I know my conversion factor is a 7. So notice that my 7 for my pancakes is over here on the right hand side is a 7. And then on the top hand side is my 6 eggs. So that's why I took my 45 times my 6 divided by 7. So someone please calculate 45 times 6 divided by 7. Let's see what we get. Let's see what we do. Let's see what we get when we do 45 times 6 divided by 7. Loud out calculator. Loud out calculator, guys. 38.571. Okay, so I got 38.571 here. Okay, so I got 38.571 eggs. Now, is this 38.571 eggs produced or consumed or remaining, guys? What is going to be this? Produced or consumed or remaining here? I still don't see a Patreon link. I got to work on a Patreon link, guys. Okay. Remaining. Okay. So that's going to be let's see. That was 38.571. Okay, good job. Good job, Jess. Good try. Good job, good job, good job. So that's going to be 38.571. That's how many eggs were consumed. Okay? Why is that consumed? Because again, we started with our cups of milk and we produced 45 pancakes. So we produced 45 pancakes, and for every 7 pancakes, we consumed 6 eggs. So this was consumed, 6 eggs consumed, and then we have 38.571 eggs consumed. Okay? Good job, good job. So, still waiting on your CV. I know, I'm sorry. So, okay. So if you said produced, it's okay. Don't even worry. We're still working on it. It's going to make sense. You're not going to get chemistry in a day, guys. You're not going to get chemistry in a day. Now let's calculate remaining. So how do I get remaining? Okay. How do I get remaining? We're going to take our eggs, our total eggs. Okay. We're going to take our total eggs from our initial eggs. So remaining is going to be 56 minus the 38.571. So someone please calculate the 56 minus 38.571. That's going to be our number of eggs remaining. Wait, do you have 56 eggs and 45 cups of milk? Yes, that's what I have. I have 56 eggs and I have 45 cups of milk. Okay? So guys, that's going to be our next calculation here is 56 minus 38.571 here. So someone please calculate that, what that would be. That's going to be approximately, what, 12 plus 6. It's going to be approximately 14. It's going to be 14 point something. 17? 12 plus 6. Guys, I can't do math. 17? You guys got both 17.429. Okay, no, I'm probably wrong, okay? So you guys got 17.429 remaining. Now, of course, in real life, we're not going to have, 17.4 eggs remaining. That doesn't make sense. So we're just going to round that to approximately 17. But that's good enough because our calculation is in terms of the appropriate sig figs here. Okay, so guys, this was our primer for today. And again, if you missed this, I am recording this whole thing so you can rewatch the whole thing tomorrow when I post it on my YouTube channel tomorrow. Before I move on, let me know if there's any questions about the stoichiometry here for the eggs versus limiting. Before I move on, let me know if there's any questions here. Okay, if you're ready to move on to a harder example for stoichiometry, go ahead and drop a thumbs up in the chat. If you're ready to do a harder example, please put a thumbs up in the chat here. Okay, and then we're going to do another example here. Guys, we have about 10 more minutes left for Gen Chem before we switch gears here to the winner of the poll. So at the moment, let's see who's the winner. If you haven't voted in the poll, make sure you vote on the top left here. What topic should we cover today? And it's super even today. We got 2 votes for Gen Chem, only 1 for OChem. Guys, where's all the OChem people? I think all the OChem people are scared. Okay, so make sure you vote on the top left-hand screen of the top left-hand side of the poll, and then I'm going to continue on here. All right, so I'm seeing some thumbs ups. Good job, everyone. Thanks for following along. Super appreciate y'all's interaction. And we're going to do a harder example. Okay, so now we need a harder example basically to determine limiting versus excess reagents, right? We need a harder example. And let's say I pick a random problem here for my textbook. Okay, I'm going to give you guys some random calculations that, guys, I'm doing these live. I don't really know what the answer is going to be yet, so we're going to answer it together. Okay, we're going to answer it together. So this time I'm going to give you SO2, okay, plus O2 equals SO3. Before we even start the reaction, what's the first thing we're going to do? Before we even start the calculation, what's the first thing we're going to do? And then I also need some units, guys. So give me some units of how many grams or moles. So someone give me a random number from 1 to 100 of grams or moles of SO2 versus O2. Okay. Jared says, give me nitrotoluene with NO3. Okay, we might try that next time. Can you do addition of bromine gas with the cyclic compound, including stereochemistry? Okay, guys, we can definitely do OChem, but if you want to do OChem, make sure you vote for the OChem poll, guys, in the top left. All right, Rosita says 23.78. 23.78. Okay, guys, suddenly we got a jump for more Gen Chem, so we might just keep doing Gen Chem. So we said we went to the store and we have 23.78. Very good. So someone said balance it. Jess, good job. Jess says balance it. So someone please balance it. Let's say we have 23.78. Jared says 16 picograms. And then Gio said 74 grams. Okay? So guys, we have 23.78 grams of SO2 and we have 74 grams of O2. See, guys, I like to do this interactive so that we are doing this for the first time together. So this problem has never been written before. It's never been solved before. So this is totally live. Okay, but before we do that, we got to balance that. Megamind says balance that stuff, my king. That's right. We got to balance that. All right, so how are we going to balance this, chat? Before we even start the stoichiometry, we got to balance that. Why is it a 2G? Why is there 2G? Oh my gosh, that's a typo. 74 grams. Thank you, Jess. So we have 23.78 grams of SO2, and okay, we have 74 grams of O2. So how are we going to balance this, chat? How are we going to balance this? What should we do first? Okay, before we do anything, step 0 is going to be balancing here. So we got to basically have SO2 plus O2 is SO3, right? I'm going to do SO2 plus O2 is SO3. So I'm going to do a 2, right? That's right. I'm going to do a 2. Okay, cool. So I'm going to do a 2 right here. So I have 2 SO3. That means I got to do another 2. I got to do another 2. Okay, Landon, I got a lot of requests for balancing redox after. How often do I do these lives, Kiki? Every single week, Monday through Thursday, right around this time. And if you miss a live stream, I started posting them on my, YouTube channel. So if you miss it, you can watch it on my YouTube channel. All right. Sulfur trioxide. Guys, we need one more thing to balance this, and we are balanced here, actually. This is all completely balanced. All right, guys, so we're going to try to calculate the moles of product and the grams of product. So what we have is 23.78 grams of SO2, a random number that someone dropped in the chat, and then what we want is going to be the grams of the product. We want the grams of SO3, guys. So anyone that's been here for the last week, what do we do for step 1? Someone help us out here. For anyone that's new here, what do we do for step 1? Always, chat. What's my best recommendation for step 1, step 2? Okay. What's going to be our step 1? Does anyone remember step 1, step 2 for these stoichiometry problems? Good job, Jess. You're cooking. Start with what we have. That's going to help you so much if you always start with what you have. So now let's go with what we have. Guys, anyone that's new here, we are doing stoichiometry, and my biggest tip for you is start with what you have. So that way you can stop asking, how do you know what we start with? Well, we start with what you have. And what do we have? What do we have, chat? So I said we went to the store. We have 23.78 grams, right? And then so I'm going to write the 23.78 grams of SO2. Okay, so now I want to convert this to grams of SO3. So I want grams of SO3, but before I do that, what do I got to do before I do anything else here? What's the very next step here? If I have grams of SO2, and then I got to convert that to grams of SO3. And I'm going to give you guys a big hint. I'm going to get out my bestie. Okay, my bestie is the periodic table. So I'm going to go to my bestie. She knows everything about the elements. So I'm going to go to my periodic table and say, hey, bestie, what do I do here if I want grams of SO2? Mr. is the ratio part. We're going to do the ratio in just a second. We find mass, molar mass of SO2. Good job, Jess and Rosita. All right, y'all are cooking today, guys. So now we go to S, and we say, hey, bestie, how much is S? And then bestie says, all right, 32.07. Okay, so let's say that we want the molecular weight of SO2. And then bestie says that S is 32.07. I'm going to round today, guys. I'm going to always round. You guys don't have to round, but actually today, let's not round. Okay, let's not round today. So let's keep it as 32.07. All right, good. Then we have 2, and then we go to our bestie and I say, hey, I have 2 oxygens. And then our bestie says, hey, oxygen is 15.99. Okay, so someone please calculate out 32.07 times 2 times 15.99. And I'm kind of tired of going back and forth between my calculator, so I'm just going to jot that out. Exactly, we go to moles. Hey, sir, can you explain area under a curved washer method? I definitely got you, twin, if that's going to be the next topic, but unfortunately today we're doing chem. If you do need help with calculus, you can definitely shoot me a DM. Okay, shoot me a DM if you want to go over calculus, and I can add you to the Discord. Okay, so let's do 2 times 15.99. So I got 64.05. Okay, 64.05. Very good, Rosita. So I got the same thing as Rosita. We're off by like 0.1%. That's fine. 64.05. This is my grams per mole. So now I'm going to use this to convert into moles, right? So now I'm going to multiply here. This is going to be, now I have my grams on the bottom, so I'm going to divide here 64.05 grams per mole. Okay, you have an option here. If you want, you can calculate this out. You can compute that if that makes you more comfortable. Compute out 23.78 divided by 64.05. That, if that makes you more comfortable, that is fine. I'm going to go ahead and skip that step and jump to the next step here. And what's going to be my very next step here? If I want to have moles of SO2, and what do I want here? Remember, this is what I have, and I want SO3. So what's going to be my next conversion factor? And guys, remember, this part is the recipe part of the calculation. This part is the hardest part for most people, including myself. Okay, if you don't understand this part, it's totally fine. It's going to take practice and practice, but eventually, I promise you will get it. Okay, so what numbers do I put up on top here? Can you do theoretical yield? Okay, we can do theoretical yield for this example. I got you, Zay. Molar ratio, good job. Ratio, exactly. Y'all are cooking today, but what's the ratio, chat? Give me the numbers. So here's my hint for you. I have moles of SO2, so I'm going to use moles of SO2, and then I want SO3, right? So what numbers am I going to put on top? Good job. Zay is cooking. Jess is cooking. Good job. Moles of SO2, and then that's going to be 2 up here, and then a 2 up here. So at the end of the day, that's going to be canceling out. Okay, and then now I'm going to calculate this out. Here, and then I'm going to cancel out my 2 and my 2. So before I calculate this out, if you understand this part of the calculation, drop a thumbs up. If you understand everything for this part, go ahead and drop a thumbs up. Exactly, y'all are cooking. So I'm going to do my 23.78 times my 2 divided by my 64.05 times another 2. Okay, so what did we all get? Go ahead and comment down what we all got here. Okay, I think I need another calculator here because this one is kind of trash here. Let me get another calculator. Graphing calculator. Okay, so I got, yeah, we're doing stoichiometry, twin. We're doing stoichiometry. Graphing calculator. Maybe I'll just use my grapher here. Okay, here we go. So what did we all get here? What was that number? 23.78 divided by 64.05. Let's try one more time. 23.78 divided by 64.05. So I got 0.371. Good job, everyone. Good job. So we got 0.371 moles. Guys, this problem has never been written before because you guys gave me random numbers. So just to show you that anything is possible, kind of. All right, so we basically got our moles of SO3 produced from SO2. What's the next step? Okay, what's the next step? So that was step 1, and we have to repeat step 1 for, remember, start with what we have. So we did it for SO2, so now we're good here. Now we got to do that again for grams of O2, right? So I'm going to start with 74 grams of O2, right? So I'm going to repeat that process one more time. So how do I get my molecular weight of O2? Okay, how do I get my molecular weight of O2? So I think Zay already calculated the grams. So Zay is one step ahead of us. But notice that I just started with moles. Okay. Thank you, Rosita. Really appreciate you. Much love. Finger heart. What's harder, stoichiometry or hybridization? Stoichiometry has more math. Hybridization doesn't have any math, but it's harder concepts. Okay, good job, Jess. Periodic table. So I already closed my periodic table. So what is it for O2 though? Remember, O2 is going to be 16. I'm going to approximate that to a 32. So I'm going to do a 32 grams per mole here for oxygen. Okay, 32 grams per mole of oxygen. Do we see how I got my 32 grams per mole? Let me just show my periodic table one more time just in case people missed that. Okay, so I have my 32 grams per mole. Why? Because I have oxygen is about 16. So oxygen is 16, but we have 2 of those. So 2 times 16 equals 32. So that's where I got my 32 right here. Okay, but I'm going to erase that because I want to save some space. I want to save some space. And then guys, don't worry, the person that asked about limiting reagent is going to be, we're going to do that next. Guys, we got 1 minute left before I close the poll of which topic we should vote for. So let me bring that up one more time. We got 1 minute left. Gen Chem is cooking today. got 1 minute left, so you got 1 minute left to lock in your vote. Gen Chem was cooking, and then physics is also number 2 here. So make sure you vote. Got 1 minute left before we lock it in for the next hour. All right, now what's the next step from here? Jess, help us out here. What's the next step if we have grams per grams, and then I'm going to cancel out grams of O2 and grams of O2. Now I have moles of O2. Now I have moles of O2, and remember, I wanted SO3. I wanted SO3 here, so I want moles of SO3. Okay, so if I want moles of SO3, what's going to be my next conversion factor here? What's going to be my mathematical operation here? Okay, this part feels like magic here. This part feels like I'm using my magic powers to convert things between units here. Okay, so I know I have O2 and SO3, right? So I'm going to put my moles of O2 on the bottom, but what numbers am I going to put on top now? What numbers am I going to put right here? This feels like I'm converting things. This feels like magic for me. We do the ratio. Good job, Jess is cooking. We do the ratio 2 moles of SO3 per 1 mole of SO2 per 1 mole of O2. Right? Good job, twins. Shouts out Jess, because I remember a couple days ago, Jess said that I did not understand how this is going, but now Jess is actually cooking up today. Okay, so shouts out Jess. We basically crushed that. Now we just have to calculate that out. So I'm going to use my calculator, and I'm going to say 74 times 2 divided by 32, right? And so that's going to be 4.62 here. Okay, so now I have 4.62 moles, and Gen Chem is the winner, guys. So we're going to keep this going for another hour. And unfortunately, if you voted for physics, guys, maybe we'll do physics tomorrow. Actually, tomorrow's Friday, so we'll do that next week. So I got 4.62 moles of SO3. So you already know what I'm going to ask you next. Okay, you already know what I'm going to ask you next here. You already know what I'm going to ask you next. So next is going to be which one is limiting. Aha. Which one is limiting? Is it going to be SO2 or is it going to be O2 again? Is it going to be limiting? Is SO2 going to be limiting or is O2 going to be limiting? OChem 2 has me missing this period. So 60 seconds on the clock. You got 5 more seconds to think about it. And all right, 60 seconds on the clock. So which one is limiting? We produced 0.371 moles of SO3 from SO2, and we produced 4.62 moles of SO3 from O2. So if you think that SO2 is limiting, you're going to vote for a happy face, okay? And if you think that O2 is limiting, you're going to vote for a crying emoji. Okay, so think you just voted happy. Doc, you got more moles of which one? All 3 voted happy. Basima happy. Jackson says happy, and Gio says happy. Okay, everyone's cooking that up. Everyone's really, really good at limiting reagents. So again, same question for you. We got 6 votes, 7 votes for SO2, and 2 votes for O2. So if you said SO2 is limiting, go ahead and comment why you said SO2 is limiting. If you said that SO2 is limiting, comment why you said SO2. 3 seconds left on the chat. And good job. Okay, good job, everyone. So if you said that SO2 was limiting, you are correct. Okay, so let's hide that here. So if you said SO2 was limiting, why do you think that SO2 was limiting? Yes, I got tutoring videos on my YouTube channel, Twin. I got all the recordings for all the live streams that I'm posting every single week up on my YouTube, as well as my TikTok. Okay, so now let's label here. We said that SO2 was limiting. Why? Because we produced less from this product here. So now we have 0.371 moles of SO3, and now we're going to have O2 in excess. So if that's limiting, then we're going to have 0 moles of SO2 is the lowest. Exactly, okay? Basima is lower. Good job. Zay said lower. It's the smallest. Good job. Basima is lower. Correct, okay? Good job, good job. All right, now we want grams of SO3. So now we're going to ignore the limiting. We're going to select the excess, which we select was 4.62 moles of SO3 from the O2. So now we say that O2 is excess. So now we're going to do step 2, which I'm sorry, I haven't been writing. Step 2 is calculate grams of product produced. Okay, so we're going to start with our 4.62 moles of SO3 from our limiting reagent. So I'm going to rewrite that, 4.62, and then what am I going to multiply here, Jess? What am I going to multiply here, everybody, if I have 4.62 moles of SO3? Okay, what am I going to multiply this time here if I want grams? Okay, what am I going to use here to get my moles of SO3 to grams? Okay, so it says Hess's law, so let me get the next topic ready while you guys are thinking about that. So I saw redox, oxidation reduction, and then I got and then Hess's law. Hess's law, enthalpy. Okay, I also got titrations as well. Yo, W, Brian says got 97 on physics. Wow, that's a W. Shouts out Brian who got a 97 on physics. Okay. All right, use the molecular weight. Exactly, so use the molecular weight. So what's the molecular weight of SO3, guys? So we got to calculate that molecular weight. Okay, so I'm going to do the molecular weight here. I'm just going to look up the molecular weight of SO3. Okay, so I'm kind of cheating here, but I want you guys to practice that out here. So I want you to practice that out here. I'm going to just switch gears here and get that as 80.06 grams per mole, and then multiply 80.06 times 80.06 times 4.62, which hopefully I think everyone's getting that. So I forgot who said that a long time ago. They got it right. They said 369.877 grams of SO3 produced. Okay, and we are done, chat. We are done. That's what we wanted. Okay, it said grams of SO3 produced. All right, guys, let me know if there's any questions here. If this is helpful, go ahead and do me a big favor and drop a cook emoji because we are cooking it up today. Feel free to take a screenshot, and if you missed any part of this, don't even worry. I'm recording every part of this live stream that you can rewatch back on my YouTube channel tomorrow, so make sure you hit that follow button and that subscribe button. Guys, I think we're going to move on to the next topic, but I'm seeing quite a lot of topics. The class we're going to do is Gen Chem because Gen Chem was cooking. But now which topic are we going to do? Is it going to be redox or thermo? I think these are the two most common here. So if these are the two most common, let's pick what we should do next. If you think we should do redox, you're going to vote for a happy face emoji. That includes oxidation reduction, electrons balancing out redox calculations. If you think we should do thermo, which includes Hess's law, heat, enthalpy, Q, you're going to vote for crying emoji. If you think none of these, then vote none and comment down which section to do next. 60 seconds on the clock starting right about now. And said also VCPR. All right, we got 1 vote each. 3 for redox and 2 for thermo. If we have enough time, we'll do both of them. If we have enough time, we'll do both. Okay, if we have enough time, we'll do both of those. And guys, anyone that is just joining in, my name is Dr. Andrew Sanchez. I do have a PhD in chemical engineering. Those of you guys that are new here, make sure you comment the word new so you can be welcomed in by all our fellow members. If you've been here before, comment another lock-in emoji because we are locked in today. We are doing general chemistry. I do go live every single week, Monday through Thursday at 6 o'clock p.m. PST or 9 o'clock EST. If you have any questions for Gen Chem, math, or physics, drop them down below. Dixon, we can definitely do titrations and buffers. If we have enough time, we'll try to do all 3. Gina is new. Welcome in, Gina. Jackson is locked in. Jada is locked in as well. Dora, we can definitely do physics twin. Zay said Hess's law. Guys, it seems that thermo won. So I think we're going to do Hess's law today. And let me know down in the chat. Guys, we're going to do Hess's law is the winner. Let me know down in the chat. Should we do college level or AP or high school level? Maybe a little bit of both. I think we're going to do college level, but I'm going to try to break it down so that everyone understands for Hess's law. Okay? And let me get some examples here. Just as college level. Marvelous. How do we go from cyclopentene ethene to 1-methyl 1-bromocyclohexane? Twin, unfortunately, we're not doing OChem right now. We can definitely do OChem. If you need help, make sure you shoot me a DM. Marvelous. Cyclopentene, ethane to 1-methyl, 1-bromocyclohexane. I can definitely help you with that, Marvelous. Make sure you shoot me a DM, okay? So unfortunately, we're doing Gen Chem right now. So we're going to do Hess's Law as 221. So guys, here's a secret. Here's a secret that I love telling people. Guys, did you know that... Okay. Did you know that... Okay, hopefully this is a good one. I remember there's a really good problem. Okay, here's a secret for Gen Chem. Did you know that Gen Chem is actually physics in disguise? OMG, what? That's right. When we're talking about thermodynamics, we're actually talking about physics. So the next topic we're going to do is thermodynamics, thermochemistry. We're going to do Hess's Law and energy and basically breaking it down. So, okay, so what are the units? What are the units for energy? What is a good definition for energy? Anyone that is taking physics right now, who can tell us what is the definition of energy? Okay, Jada says we're starting thermo tomorrow. Don't you dare say that again. Jared is a big chemistry fan. So, guys, we're going to do energy. So, thermodynamics is the study of energy. We're going to do thermodynamics is the study of energy. So, what is the definition of energy? Okay, energy, think about like how much energy you have. Like if you're charging your phone, right? If you're charging your phone, you need to give your phone energy, right? So I gotta basically charge my phone. I gotta add energy into my phone. So that means I'm giving my phone energy. Or if I drink some water or if I eat some food, I'm giving energy into my body, right? That's called thermodynamics. That's the study of energy is thermodynamics, okay? So now in the context of chemistry, energy is the capacity to do work. Energy is defined as the capacity to do work. Okay? And it can be converted into heat energy. Energy is the capacity to do work. Okay? So if we're in a physics class, we're going to learn what is work. But in our case, we're going to talk about heat energy. And so heat energy is going to be given by this equation. So heat energy is going to be given by this equation called Q. Why is it Q? I don't know. I wasn't there. I would have said heat is by H, but they said that Q is heat. Isn't that crazy? The scientist is, out of all the letters to pick, they decided that heat was going to be in Q. Okay, so the equation reads Q, which is heat. Heat, Q equals mCp delta T. Guys, what do each of these terms mean? Does anyone know what does each of these terms indicate here for our equation for heat? mCp delta T. Stop, we're literally learning about this right now. Now you get to learn about it again, twin. Laplace transforms. Calgary 5 is advanced for engineering. Q equals MCAT, exactly. Subby, you can send problems up on my link in bio, engineeringminds.co, or shoot me a DM, twin. Okay, good job, good job. Everyone is cooking up. Guys, this is the equation to cook up. This is the cook up equation. This is the cook up equation. Why? Because if you want to cook up something, then you're going to add heat into the system. Okay, so M is going to stand for mass. M is going to stand for mass, and it's actually in grams. It's usually in kilograms, but let's say that M is in mass. And the heat capacity is going to be, let's talk about heat capacity in a second, but CP stands for heat capacity. And heat capacity is basically a number that a substance has that tells us how much energy is required to change the temperature. And then as Jess indicated, this is the change in temperature. Now, we're not going to be talking so much about heat. We're going to be focusing on enthalpy. We're going to be focusing on enthalpy. And then there's another number right over here. So there's already a problem up on my website where you can watch that you can solve this problem. You can do examples on Q equals MCP delta T. Now, I do want you to note this because this is the most important equation, but we're going to be focusing on Hess's law. Okay? We're going to be focusing on Hess's law. But before I talk about Hess's law, I want to tell you about this thing that everyone gets scared about called enthalpy. Everyone gets scared about this thing called enthalpy, and it's given by this thing called delta H. So if you see this thing called delta H in your classes, don't even start tripping out, okay? This delta here is a Greek letter. This is called delta. Guys, what does delta indicate? Anyone that's taken any calculus classes or math classes, can someone tell us what delta indicates? And then delta H here is going to be another constant here. This is going to be H. H is going to stand for enthalpy. Okay, so you can think of enthalpy, okay, you can think of enthalpy as the energy of a reaction. So it's the energy of a reaction. So for example, if something is reacting, let's say I'm cooking some food and I'm releasing energy, then I'm producing energy. Exactly, right? So delta is going to stand for change in. Okay, change in. Okay, and if I'm freezing something, like if I'm freezing a cup of water, turning it into a water from from a liquid water to ice water, that's going to be absorbed, that's going to be releasing energy. So think of enthalpy as basically the same thing as energy. Okay, it's basically the same thing as energy. Okay, cool guys. Trying to catch up to the chat. Heat transfer was my least favorite class, bro. Heat transfer was one of my favorites. Learning this in biology, exactly, because biology actually has thermodynamics. Isn't that crazy? It's almost like we're made out of physics. It's almost like the whole universe is actually made of math. And technically we're made of math, guys, because everything is about thermodynamics and particles. All right, so now this is enthalpy. So we're going to focus on Hess's law. So anyone that's joining in, we're talking about Hess's law, okay? Just wanted to give a quick recap of thermodynamics is the study of energy, where energy is defined as a capacity to do work. And the equation for heat is given by Q. Why is it Q? IDK, I wasn't there, but they decided to go with Q equals MCP delta T. We're going to do this equation another time, and we're going to focus today on enthalpy. Okay, I wrote Q because I want you to know it here, but we're not going to do any examples on Q. We're going to focus on examples on enthalpy because I want to say that people get scared about when they see delta H. Don't get scared when you start seeing delta H. Okay? So, here's how we're going to do delta H here. All right? And hopefully I can find a good example here. Here we go. Now, the equation for delta H is going to be written like this. Okay? Guys, don't be scared by the math. The math is just the math. The total delta H of a system, of a reaction, is going to be equal to the sum of the delta H, okay, of the products, okay, of the products minus the sum of all the delta H's of the reactants. What does that mean, guys? What does that mean, guys? Don't even start getting scared. When you start seeing the funky looking equations, people start getting scared, and they like, I see some memes and TikToks where people are like, oh, I'm gonna drop out. No, guys, don't even give up. Okay, this delta H is our change in enthalpy. Delta means change in, and then the summation means that we're adding up all the products. So we're adding up all the products. This means we're adding up, okay, adding up all the products. Adding up the products, and then we're going to subtract, okay, we're going to subtract all the sum of the reactants, adding up all the reactants. Don't even worry, we're going to do some examples. Before we do some examples, any questions about enthalpy and about these equations? Okay, you better sign delta H positive to the system, not the surroundings. Bro, you already know that I put delta H into the system as positive, okay? Do you do MCAT content? Well, I do STEM content, and I know MCAT has STEM for sure. Okay, I think I see pre-calc symbol. Exactly. There's going to be some pre-calc symbols here. This is going to be the summation. So don't even start freaking out when you see the summation symbol. This just simply means, hey, I'm going to add it all up. Okay, why did we add the F? The F, okay, good question. The delta H of the formation is basically the F indicates that we're forming the heat of the reaction, okay? Jared says triggered. Do you do private tutoring? I absolutely do, Nana. I got you for private tutoring for math, chem, and physics. Okay, if you want to sign up for private tutoring, you can either shoot me a DM here on TikTok or sign up at the link in my bio. Why is oxygen gas zero like in a reactant? Why is oxygen gas zero? Well, the gas for pure elements, it's going to be zero. And the small zero, what is that? Okay, really good question, guys. Let's talk about the F. So the F is going to stand for formation. The F is going to stand for formation. And so that's going to be the energy required to convert liquid into vapor, or vapor into gas, or vapor back into liquid. So vapor into liquid or liquid into vapor. And someone asked about the zero. So the zero is called a reference state. And think of the reference state as like a baseball home base. So reference state is our home base. So what we're going to be doing is basically going to the baseball game. So in a baseball game, we're going to go away and then we're going to come back home. So here's first base. No, here's going to be home. First base, second base, third base, and then we're going to go back home. So the home base is what's going to be called the reference state, okay? This is an analogy because thermodynamics is inherently extremely complicated. And so the reference state, the little circle thing, indicates that we're going to essentially go back home. What is home for chemists? Guess which compound was home for chemists? They said that the home was H2O liquid water at 25 degrees Celsius, okay? So that's going to be our home base for us chemists, that they said, hey, you know what? Let's make the reference state liquid water at 25 degrees Celsius, okay? Guys, if that made sense, go ahead and drop a thumbs up if that made sense so far for enthalpy, okay? If you're ready to move on for an example of enthalpy, go ahead and do me a favor and drop a thumbs up, okay? We're actually doing chemistry here, twin, for enthalpy, okay? All right, cool, guys. Awesome, awesome. Super appreciate you guys' interaction. Guys, this is a pretty hard topic, but don't even start worrying about it. The hardest part is getting over the fear. I don't want you to be scared when you see the symbols. Don't even be scared about those symbols, okay? This topic is actually not too bad if you break it down slowly. Okay, so I'm going to give you a reaction, and then we're going to calculate this out. So here's our first example. We're going to get the total enthalpy. We're going to get the total enthalpy of this reaction here. So I'm going to say CH3OH plus 3O2 gas, okay, equals 2 CO2 plus 4 H2O. Okay, so what we're going to do is we got to calculate the total enthalpy of the system. And they're also going to give us some data. Okay, guys, so then what they're going to give us is the data of all the delta H formations. So they said, hey, we went out into the lab and we calculated all these datas here. And the delta H is going to be in kilojoules per mole. I forgot to mention the units, guys. Joules is a measure of units. I forgot to mention that joules is a measure of units. So this is going to be in kilojoules per mole. Well, joules is a measure of energy. So joules is spelled J is in joules, Joule. This is a unit of energy. Okay, we already know about moles, right? So delta H is kilojoules per mole, right? Jared says methanol. This is organic. This is organic combustion here. Okay, and so this is our kilojoules per mole, and then so they went out, they did the experiment, and they said, hey, the delta H for methanol is negative 201. They're gonna give you this. They're gonna say the delta H is 0, and someone asked, why is it 0? It's 0 for all the diatomic gases. So it's 0 for all the diatomic gases, so that's why it's 0. And then it's gonna be negative 394. Okay, minus 242. So I'm going to use, and we have to calculate delta H. But before we do, we have to basically multiply by these numbers here. So what do? I go back to my equation. And wait a second, my equation, let me guys, before we do the scary equation, let me show you how easy this equation actually is. So we're going to box the scary equation, but actually I want you to box the easy equation. The easy equation is delta H equals products minus reactants. Delta H equals products minus reactants. So that's how you make the scary equation actually low-key easy AF, because the delta H is what we're trying to calculate. So my products here, what are my products? What are going to be my products here on this hand side? Okay. I'm going to say you're chemical engineering. I've only done Gen Chem 1 and 2. What's the thing over the mole? I can't see. Oh, sorry, twin. This is kilojoules. Okay, so kilojoules is my unit of energy. So guys, this is the easy equation. So when you start seeing the scary equation, don't even start getting scared. This is the easy equation. Very good. So the products here on the right hand side. So I have CO2 and H2O. So I'm going to write my delta H equals my products here. So my products is my CO2, but I'm going to say that I have 2 of those CO2s, right? 2 of those CO2s plus 4 of those H2Os. All right, what are my reactants here? So that's my products, 2 CO2 plus 4 H2O. So that's my products. What's my reactant side now? What's my reactants? It's more important for me to take thermo. CO2 and H2O. Good job, good job. Good job, Jada. So Jada says the left-hand side. So now my reactants here are going to be on the left-hand side, chat. So I have 2 CO2 plus 4 H2O. And then on the left-hand side, I have minus, all right, I have 2CH3OH, 2CH3OH, right? Plus 3O2, right? So this is my scary looking equation. Look how simple that actually is. My scary looking equation said I had to add up all the products minus all the reactants, and it simply turned into, oh, delta H, products minus reactants. Can you tell me about what delta H influences the equilibrium temperature? Jackson, that's where Jackson comes in. Jackson is our thermodynamics expert here in the chat. Okay, good job, guys. So now we have to basically replace over here. Now, delta H is going to be a function of delta G. So if you guys want to talk about the theory and we want to go at the engineering level where you can do advanced thermodynamics, because in chemical engineering we take this a step further. We can definitely talk about delta H theory if you guys want. Now, we're going to plug this in though. So let's not talk about theory too much yet. We're just going to plug this in. We have 2 times negative 394 plus 4 times negative 242, negative 4 times 242, minus, because I ran out of space, I'm going to move down here, 2 times CH3OH, which is 201, plus 3 times 0. Okay, so the reason I had, again, 3 times 0 is because this is a gas, and all the gases, let's box that somewhere. Where should we box that, chat? All the diatomic gases are 0. Why? Because back in the day, they said, you know what, twin? Let's just make all the gases easier. And they said, you know what, bet. You know what, bet. I kind of want to make my life a little bit easier. So they said, hey, twin, can we make, is it cool if we make all the diatomic gases 0? And they said, you know what, bet. All right. Cool. Oh, diatomic gas twin is when we have 2 of the same compound. So that's going to be Hoffen-Berkel twin. So Hoffen-Berkel. Guys, who remembers Hoffen-Berkel? So diatomic gases are going to be H2, O2, F2, I2, N2, Br2, and Cl2. This is called Hoffen-Berkel. I think someone else calls it something else. You guys called it like, this was my generation. I'm a millennial, guys, but I think Gen Z uses something else. I think you guys, I think the Gen Z teachers do like something else now. It's like Berkel or something like that. Oh yeah, Birkenhoff. So in my generation, I use Hoffen-Berkel, but in your guys' generation, you guys use Birkenhoff. How do you get these numbers? These were given in my example twin. So these are going to be in your textbook. These are going to be what your professor or your teacher gives you in the problem statement. So they're going to give that to you. Okay? So guys, now we need to compute this out. We need to basically multiply out 2 times 394, 2 times negative 394, 2 times negative 394, okay, plus 4 times negative 242, okay, minus parentheses 2 times negative 201 times 0. So I got minus 1354. So I got my delta H final answer equals negative 1354. Guys, this is all you need to do for Hess's law. If there's any questions here, drop them down below. If this made sense for Hess's law, go ahead and do me a big favor, chat, and drop a thumbs up and a pot emoji, a cooking emoji or a pot emoji to let me know that this made sense, guys. Is that a 3.0? That was a 3 times 0 twin. That was a 3 times 0. Yeah, guys, I don't know how to write better. I'm really bad at writing on my iPad. And then that's going to be all that. Okay, so Jackson says cooking. Brian says cooking here. Okay. Can you do more regular products to reactants? Just got in here. Jimenez says, can you do regular products to reactants? So if you just got here, I recorded the whole thing, twin. So I'm going to post the whole thing up on my YouTube channel tonight. Okay, so make sure you hit that follow and that sub so you can rewatch the whole live stream again. Okay, negative 1354 kilojoules per mole. So wouldn't it be negative 1354? That's what I wrote. That's right. Isn't that what I wrote? Negative 1354 kilojoules per mole. This is going to be per mole because our delta H is in terms of moles. So we don't have any moles here, not per mole. I disagree, Dallas. Okay, so Dallas said, hey, isn't it negative 1354 kilojoules, not per mole? The reason I did moles was because we don't have the amount of moles in the reaction. So this is a per mole basis. Okay, so they said that our delta H was in kilojoules per mole. So that's actually going to be, okay, that's actually going to be the total number of kilojoules per single mole. Do you want to say it's exothermic? Oh, okay, good job. No. So no said is something exothermic or endothermic. So if delta H is negative, okay, good. If delta H is negative, then it's called exothermic. So what does exothermic mean? It's exothermic. So exo, think of like exit. Exo is exit. So we're losing heat. We're losing energy. If delta H is positive, okay, if delta H is positive, then it's called endothermic. So endo, think in. Okay, they're definitely going to ask you. They're definitely going to ask you is something exothermic or endothermic. If delta H is negative, you're going to say exo is exit, exothermic. And then delta H is positive, think endo in. Okay? All right, good job, everyone. Guys, how are we feeling about this topic? I think we gotta move on to, this is gonna be delta H. We're gonna do redox reactions because I gotta end it soon. Can you explain what is standard start and standard formation reaction? Standard start and standard formation. Thank you for explaining that like a chemist and not a physicist. You're welcome, Jared. Standard state. Okay, standard state is basically the, standard state is basically I like to think of standard state. Here's an analogy. This is not true. This is an analogy. Okay, so a baseball diamond has a home base here, and then reference 1, 2, 3. So what we're doing basically is going all around the base here. Okay, analogously. Why? Because technically, quick calculus side note. What we're doing, guys, is actually we're actually doing the gradient FTC from calculus. So quick side note here. So don't worry about this, but this is more from physics. So we're doing this equation here, F dot dr. Okay, so this is called the gradient FTC from calculus. And so what that means is it doesn't matter which path we take. It doesn't matter if we go from 1, 2, 3 and then coming back home. It just simply means that we're at the home base, or we go 3, 2, 1. If we come back home, we're coming back home. And so home for chemists, the home base, they call that the reference state. So the reference state is denoted by the delta H with a little 0 on it for water. And so for water, it's going to be liquid water at 25 degrees Celsius. So what is the reference state? It's basically the home base that the chemists back in the day said, hey guys, is it cool, twin, if we make the reference state for delta H liquid water at 25 Celsius? And they said, bet, twin, let's make the reference state for water at liquid room temperature at 25 degrees Celsius. Okay, so that's going to be at 25 Celsius. Okay, so in Kelvin, that's going to be 298 Kelvin. Okay, so don't worry too much about the reference state. That's more of like a theory thing. That's more of like a notation thing. So this is more like a little bit more deeper, like theory. Don't worry so much about the theory. I want you guys to focus more on this equation. Delta H is products minus reactants. Okay. Cool. So guys, how are we doing here? I think what we're gonna do is, let's see. Let's do another poll real quick, guys. Let's do another poll. Same topic. Or a different topic. Okay, so are we going to do the same topic, or are we going to do a different topic? So guys, let's bring this up. And guys, it's going to be our last topic, so vote wisely because this is going to be our last topic for today. So are we going to do the same topic and do more examples for thermodynamics, or are we going to do a different topic for the last one for tonight and do redox reactions? No, thank you for the roses. Thank you for the 10 roses. Vote carefully because this is going to be our last topic for today, but don't even worry. We are going to come back next week. Okay, quick poll is live, and quick poll is active in 3, 2, 1. All right, 60 seconds on the clock. Guys, thanks everyone for joining. We got over 34 people in the chat currently. We had 50 earlier, and we just hit 1.5k likes. Guys, we did a lot today. We did stoichiometry, we did thermochemistry, we did limiting reagents, we did moles to moles ratios. If you missed any part of this live stream, don't worry, I'm going to be posting this up on my YouTube channel tonight. So make sure you hit that follow button. Make sure you subscribe. We gotta do one more topic, guys, because I got to head out shortly. So unfortunately, I'm gonna end it soon. So this is gonna be our last topic. If you want to do the same topic, make sure you vote for the oh wait, I missed the I made that kind of confusing. So if you want to do same topic, do thermo, but that's crying. Okay, so same topic is thermo, but that's crying. And then yeah, redox is happy. My bad, twin. Okay. So Zay says lock in for thermo. No says 2 for thermo. So I'm thinking thermo's going to win. So next week we can do redox reactions. And don't even worry. Like I said, I'm going to post this up on my YouTube channel. So 7 for thermodynamics, guys. Thank you guys so much for joining. This is going to be our last topic for today. And then I will end it. But don't even worry. I go live every single week, Monday through Thursday at 5 o'clock p.m. PST. 8 o'clock EST. If anyone needs any help for math, chemistry, or physics, you can sign up for a free consultation call at the link in my bio. I got you for various STEM subjects, twin, for mathematics, whether it's calculus, pre-calculus, trigonometry, calc 1, 2, or 3, physics, AP physics, general physics, college physics, or Gen Chem, OChem, and engineering. Just go to engineeringminds.co and sign up for a free consultation call today. Okay, guys, we're going to basically continue our topic from thermodynamics. And then now what's going to be the next thing for thermo? What's going to be the next thing we got to talk about for thermo? Basically, we have ideal gases. We have bond energy. We have bond enthalpy. We have specific heat and calorimetry. So I think the next thing we got to talk about is calorimetry. Guys, let's do calorimetry and then we'll end it for today. If calorimetry is a good old topic, let's see some thumbs up down in the chat. If calorimetry is a good topic to finish off today, please, please, please drop it. Thumbs up down in the chat. Zay is really, really happy. Zay says, thank God. And who else is happy? Dallas says, yes, Dallas. Zay, thumbs up. Valerie says, thumbs up. Awesome, my friends. Awesome, my friends. Okay, and so last thing, guys, I'm just going to advertise one more time before we do this topic here. Again, you can sign up for a free consultation call at engineeringminds.co. You can join the Discord. Anyone that's in the Discord, make sure you're going to be super, super nice. So the Discord is free. Just click this link that says Discord. You can click this link that says Explore Resources. We're going to add up all the topics that we talk about every single week. And then you can drop in your questions here. So again, that's engineeringminds.co. All right, guys. So last topic for today is going to be thermocalorimetry. And this is going to be our Q equals MCAT equation. So as a matter of fact, the reason I brought that up is because I already have an example here in the resources page. And I'm going to go over here to the chemistry page. And then I'm going to go over here to the one that says calorimetry practice problem. Okay, so we're going to answer this problem today. That says constant pressure calorimetry. So this is a typical problem. And so guys, we're going to lock in. This is a college level problem and it's going to feel complicated at first. It's going to feel overcomplicated and scary at first, but trust me, if you break it down step by step, it's going to make sense. Okay. All right. So this is our constant pressure calorimetry problem. And we're going to break this down step by step and do this problem here and lock in together. This one's going to be straight from the website, on the website that you can drop in and practice that out here. All right, cool. So this is how the calorimetry problems typically read. It says calculate the heat of combustion, which is our delta H. Now we did our delta H equation. Now we did our delta H example. So now we know what delta H is, right, guys? So who can tell me what is delta H down in the chat? Calculate the delta H of combustion when 1.01 grams of sucrose is burned in a calorimeter. Okay, is burned in a calorimeter, and the temperature of the system rises from 24.92 to 28.33 degrees Celsius. All right, and the calorimeter contains 200 grams of water and has a heat capacity of 4.9 kilojoules per degree Celsius. And the specific heat of water is 4.184 joules per gram degree Celsius. All right, so I know this can be overwhelming and scary, so we're going to break it down. But again, if you want to see the whole problem solution on your own, it's already up on my website. All right, so first things first, enthalpy gain lock-in. Guys, let's see some, like, when we get the answer, I got to see like a ton of like fire emojis, cook emojis, you know, because enthalpy is like the study of like, you know, heat, fire. So like we are cooking today. We are cooking. All right. So the first things first, I'm going to write the equation here. Actually, before I even do the equation, I'm going to draw a picture. What's even going on? What's even going on? Well, I have, what was that? I'm going to draw a picture. I have this. Okay, come on. I want to draw a box here. This is my calorimeter. There we go. And let's see if I can draw some water here inside the calorimeter. Make that really nice and thick. So this is going to be our nice and thick calorimeter here with the water here. All right. So here's the calorimeter, and let's see what's going to happen here. Let's reread the problem one more time. So the problem says, okay, 1.01 grams of sucrose is burned in a calorimeter. So we have the sucrose here. We have the sucrose, so we have like some mass of it. Okay, so this is going to be our C12H22O11. All right, and we're going to burn up that, we're going to burn up this sucrose. Okay, so we're going to cook this up. Now, it's in the water, and the temperature of the system rises from 24.92 to 28.33. So we're going to say the temperature rises. So I'm going to say T0 equals 24.92 degrees Celsius to T final equals 28.33. So 28.33. This is going to be our final temperature versus our initial temperature. Exactly. This is literally cooking up sugar. We're literally cooking here, guys. This is cooking up sugar in a hot pot here, right? Okay. So what's the first thing we got to do? And let's keep reading. Let's keep reading. The calorimeter contains 200 grams of water and has a heat capacity of 4.9 kilojoules per degree Celsius. So the water has a mass of 200 grams, and the heat capacity of the calorimeter is, okay, 4.9 kilojoules per degree Celsius. 4.9 kilojoules per degree Celsius. By the way, this problem was submitted by one of our members that we did like a couple weeks ago during the live. So this is actually one of the review questions. So the specific heat of water, now let's write that down. Please, please, please memorize that. The specific heat of water of H2O is, okay, 4.184 joules per gram degree Celsius. 4.184 joules per gram degree Celsius. Okay, cool, great, love it. So now what we got to do? We got to basically lock in, and we're running out of time, so we got to lock in and solve this equation. So I'm going to use the equation, which was what again? Q equals MCP delta T. Now, if this reaction is producing heat, that means that the water is absorbing heat, right? Right? That's the key here. If the Reaction is producing heat, it's releasing heat. That means that the water is absorbing heat. So here's going to be the magic reaction here. This is the magic equation. Okay, if basically the total energy of the system, here's what I'm going to do. The total energy of the system is whatever's the energy of the water plus the energy of the calorimeter. And then guys, I need to double check also if this equation is true or is going to be equal to each other. So I'm going to put a caveat to double check this later, because I also have to double check. Perhaps we might have the calorimeter is equal to the negative Q of the water. That can also be it. But for today, I think I did this here. So I think I'm going to do this. Q equals MCAT. Exactly, right? So we're going to get the Q of the water first, and then we're going to do the Q of the calorimeter. And then I might interchange my capital Q and my lowercase q. So let's just turn that into a lowercase q. Okay, so let's get my Q of the water first. Let's get my Q of the water. So my Q of the water is basically going to be the M of the water, okay, H2O times the heat capacity of H2O times my change in temperature. All right, so let's get my change in temperature here. So my change in temperature is basically going to be, let's plug these in. So I have 200 grams, okay, of H2O times my heat capacity, which I said was 4.184 joules per gram times degree Celsius, okay, times my change in temperature. So what's my change in temperature? That's 28.33 minus 24.92. Okay, so that's going to be my Q of water. All right, cool. So let's try that out. So I'm going to do this calculation here. I'm going to do this calculation. I basically have 200. Okay, so I'm going to do 200 times 4.184 times 28.33 minus 24.92. Okay, cool. So let's see. And then I got, wait, what did I do here? What did I get negative? Oh, okay, I put a number wrong here. 28.33. 28.33. Okay, cool. So I got 28.54. So I'm going to say the Q of water is 28.54. Okay, and that's going to be in joules. Good job. 23. Let's do that. 23. Good job, Zaze. Am I saying that right? Zaze. 28.285. I keep saying 28.2853.488. Okay, good. Joules of H2O. Cool. Now we got to repeat that one more time for the heat absorbed by the calorimeter. Okay, now we got to repeat that for the moles of the calorimeter. My friend says I need help in chemistry with moles, mass, etc. Bro, check out my YouTube channel. I went over some of those topics that I went over yesterday. You can check that out on my YouTube channel. Okay, so now for the calorimeter, how do I do that here? Well, now we're going to basically use another equation for the calorimeter. QCal equals the CP of the calorimeter, which we don't need the mass for it. We just need the calorimeter and times the change in temperature. So this change in temperature is the same, and this calorimeter was given. They said, hey, the calorimeter was 4.9 kilojoules per degree Celsius. So I'm going to do 4.9 kilojoules per degree Celsius. I got to multiply by the conversion factor. 1 kilojoule is 1,000 joules, and then times the change in temperature again is 28.33 minus 24.92 degrees Celsius. Okay, let me know, guys, let me know if this is making sense or if we're getting cooked up here. Okay, and then we're going to do 4.9 times 1,000, get that calculation. 4.9 times 1,000. 4.9 times 1000 times 28.33 minus 24.92. Great. So I got 16,709. Zay, let me know if you get that. I'm converting kilojoules to joules, twin, because I want everything in joules, but they gave it to us in kilojoules. Okay, good question. So I'm converting kilojoules to joules because I have joules here. All right, great question. So let me know if you got that, twin. I got 16,709 joules, right? 16,709 joules. Jada says I'm getting cooked. Jada says I'm getting cooked. We are indeed, because this is calorimetry. Aha, and we're cooking. Aha. All right, now I got to do the total energy, and I got to just add what I got here plus what I got over here. So I'm going to take my Q of water. So I'm going to say the Q total was my Q of water plus my Q cal. And my Q of water was 2853.488 plus 16,709. So I'm going to take this 709 plus 2853.488. So I got 2853, 16,709. 19,000. I got 19,000. Q total is 19,562. 19,562. And this is in joules. Now, I need to get the negative here. Why do I gotta add the negative here? Ooh, that's really tricky. Why do I gotta add the negative? Okay, the negative is basically where the energy is transferring. Is it going to be going into the reaction, or is it going to be leaving the reaction? Charlie, do you know any of good videos that explain Schrodinger's math behind the electron configuration? You're gonna have to look into your quantum mechanics, Charlie. Look into some quantum mechanics lectures. There probably are, but I haven't studied that enough. 2853.488 seems incredibly familiar to me, and I don't know why. Huh, that's really crazy. All right, so that's going to be my negative. And again, this indicates that it's exothermic, so energy is leaving. Okay, and we're almost done. All we got to do is just convert our grams into moles. So we got to go back to how many moles of sucrose do we have? We had 1.01 grams of sucrose. So we had basically 1.01 grams of sucrose. I'm going to use S for sucrose. Divide by the grams per mole, which they gave us as 342.3 grams per mole. 342.3 grams per mole. And then I'm going to get this value. So I'm going to do 1.01 divided by 342.3, and then I got 0.00295. Okay, that was moles of sucrose. And then all I have to do is take my 19,562 divided by 0.002, and then I'm done. So that's gonna be my delta H. Final answer is 19,000. Hopefully you guys can see that. The live will be posted tonight, twin, up on my YouTube channel. The same as my TikTok name, drandrew.sanchez. 19,562 divided by 0.0029506. So I'm going to just take my original number, 19,562 divided by 0.0029506, and I got 6.63, but again negative because it's exothermic. So my final answer, chat, my final answer for tonight is negative 6.63 times 10 to the times 10 to the 3 kilojoules per mole. And we are done. Okay, guys, The first time you do this is going to feel scary and confusing, but don't even worry. Just rewatch it multiple times. I promise it will make sense. Guys, thank you so much for joining. I'm going to be on for about 3-4 more minutes. This is your last chance to ask any last minute questions, and then I will be gone for today, but don't worry, I will be back next week, every single week, Monday through Thursday. When's the best way to recognize the power rule, quotient rule, etc. when taking the derivative? The best way to recognize is your composite functions, munchies. So if you have a composite function, that means you're going to use the chain rule. If you have a number on the power, that's going to indicate you're going to use your power rule. If you have a number in your exponent or your denominator, that's also going to indicate power rule. For a quotient rule, that's going to indicate if you have a product of a ratio, so you're going to have a rational function. For example, x to the 5 divided by x to the 3 plus 3. Now you're going to need your quotient rule because you're dividing. And then for your chain rule, that's going to be for a composite function when you're taking the derivative of a function within a function. Why is it negative? Because it's exothermic, because the energy is being released into the system. Okay, the negative indicates that we are exothermic. What's the difference between delta sign and delta H? Do they both mean going through heat? Delta simply means the change in that quantity. So change is final minus initial. Thank you for the roses, Monchis, appreciate you. And the change indicates the state, the final state minus the initial state. And that's going to indicate what is the total energy difference there. Of course, twin. Do you do live about sequences, power series, ratio test, convergence, and divergence comparison? I have not done that recently, but we can definitely cover calculus 2, power series, convergence, ratio test, etc. Of course, my pleasure, guys. Everyone, thanks so much for joining. I'm going to pretty much end it here. Again, if you do need any help, you can sign up for tutoring at the link in bio, guys. Go to engineeringminds.co. I got you covered for mathematics, chemistry, physics, and engineering courses. The first consultation call is 100% free, so you have absolutely nothing to lose by signing up for a consultation call there. Thank you, guys. You can also join the Discord as well. Discord is totally free. Just tap that link that says Discord. You can join it and ask your questions there. I think you're going to cook your midterms, Zay. I got a Calc 2 next week and I'm cooked. Rosita, don't be scared. How much for after? Thank you, Jackson. Alright, guys, pretty much gonna end it here. So I will see you all in the Discord. And yeah, I gotta do a live stream tutoring session tomorrow in the Discord. And I will be back next week for the next session. You can catch this up on my YouTube channel later tonight as soon as this is done processing. Peace out, my friends. Make sure you hit that follow button, and I will see y'all later. Thank you. Good night, my friends. Peace out.